So hello guys, welcome back to practice channel of Geeks for Geeks, and today we'll be solving another problem, and this problem is from the problem of the day. So today's problem of the day is that we have to find an element in the sorted array using the ternary search. So we have done this question with the help of the binary search, right? So let us first of all take an overview or recap at the how we can find the element in the binary search, and we will extend that binary search approach to find the element using the ternary search, right? So to begin with, I will. So we know that we can apply binary search only if the array is sorted, right? Whether the array might be sorted in ascending order or descending order, right? So let us take in this example that the array is in sorted order. So if I consider my array as 1, 2, 3, 4, 5, 6 and 7. For time being, let us keep these 7 elements in the array, and we have zero based indexing in that array, right? So after that, we in the binary search we take two variables, right? First of all, we determine the search space, right? So how to determine the search space? We have two variables, that is low is equal to 0 and a high variable which keeps the last index, right? Because we search, we return the index, right? So that's why if we are returning the index, then we will keep high as n-1, else we can keep it n, right? And also, so now, but one thing to note here is that the element at nth index will not be in the array, right? So if I'll be comparing with array of n kind of thing, so it will give me out of bound error. So we have to keep it low 0, and we have to take the indexes only in the low and high, right? So yeah, this is the logic of taking low as 0 and high as n-1. So after that, after determining the search space, what we do, we find the mid, right? We find mid, and we check in the third step, we check the mid whether it is equal to our answer or not, right? Answer, or the, I can say the value I have to find, I will say it find well, right? If it is equal, then we return answer, right? Else we shift our search space to the left side or the right side depending on the condition, whether our mid element is less than, or the element we have to find is less than mid or greater than mid. If the element we have to find is less than mid, then obviously we have to search. Suppose we have to find element number 2, right? Element 2, and our mid is suppose at 4. So we know that array is sorted. So in the left side of the mid, in the right side of the mid, all the elements will be greater than 4, and 4 is also greater than 2. That means all the elements on the right side of the 4 will also be greater, right? So we have to search in the left side only. So we shift our search space to the left side, and in the vice versa condition, when the element we have to find is greater than the mid value, then we will shift in the right hand side, because all the elements in the left hand side will be shorter than the element we have to find. So that is the condition, right? So this is how the binary search is implemented when we have to, when we are given a sorted array and we have to find an element in log base n time, right? So the, let us now discuss the time complexity. I'm One thing to note here is that I am only discussing the like the crux or the some summarizing binary search, right? Because I'll be using these concepts only to extend this concept into the ternary search. So time complexity of this binary search is log base 2n, right? And uh, okay, so that's it. Let us now extend the ternary search. So we can understand from ternary, word ternary, that is, in this binary search, binary means dividing into two, right? In ternary search, what does it mean? I will be dividing the array into three parts. Okay, because in binary search I was dividing the array into two parts and shifting in either of the half. Right? So in this case, the half was at 4, assumed half was at 4, and we were shifting in the right side or the right side according to the condition. So in ternary search also, if I take this array, right? So what do I do in ternary search? I will divide my array into three parts, right? So what I'll do, suppose if this is my array 1, 2. So from here onwards, we'll be discussing the ternary search. Okay. So From here onward we will be discussing the ternary search. So yeah, let's see now. So if I draw my array, right? So this was my array 1 2, because the array should be sorted for using binary search or ternary search. So now what will I do? Okay, so these are my 10 elements. I'll do indexing for them. Okay, so these are my indexes and these are my element values, right? So after drawing this array and the indexes, we will divide the array into three parts, right? So how will we divide? In binary search, we use the formula for dividing. Okay, right on here. For finding the mid element in binary search, we use the formula of what? Low plus high minus low by 2, right? This is how we find out low or the mid value in binary search. So before moving on, I'll be explaining you. Most of the people don't know why we use this formula. They just normally mug up this formula and they use everywhere whenever they apply binary search, but they don't know the reason or the pictorial depiction of how this formula is coming up. So I'll be discussing this formula because in this ternary search we'll be computing two values of mid, that is mid 1 and mid 2, right? So for understanding the mid formula in ternary search, we first of all have to learn how the formula of low plus high minus low by 2 comes in the binary search. Okay. One more thing, that in binary search, I will binary search mid. Okay, so let me erase it here. I'll be discussing in the binary section part only. Right. So from here, I'll be discussing. So in the binary search, we found out mid by low plus high minus low by 2, right? So suppose if I am given this search space, right, it is having some elements. So if I say I want to find the middle value, right? So how will we do? How to find out that it is my search space? We subtract high from low from high and divide it by 2, right? Suppose if I say you have the range from 2 to 8. So how will you find the mid value? You will subtract 2 from 8, so it will give the range to me after subtraction, and if I divide by 2 I will get the half of that range. So high minus low will give me the range, and by dividing it by 2 I will get the middle element, right? But now the comes factor of low plus, right? So why low plus? So if we are applying low plus because high minus low by 2 is giving us the middle element, right? Middle value, but we have to find the index, right? Suppose if my starting is this, so in comparison, in relativeness to this two, where will be my mid? So it will be only when I'll add that mid value to this, right? So let us suppose if I'm having this array 9 and 10, right? So if I'm finding the mid in this, okay, so if I do high minus low, because high is an index and low is also an index, right? So suppose consider these are my indexes. So 8 minus 3 by 5 for mid value. Okay, if I do only this, so 8 minus 3 will fetch me 5 and 5 by 1, right? So what I get? 1. So 1 depicts that element number 1 be the mid, right? From the left hand side, element number 1 will be the mid. But did I get the index? No, I didn't get the index, right? I just got the value which will be the middle one. To get the index, we have to add the starting pointer also, right? So if I add 1 to 3, then I'll get the index. I hope you're getting me, right? It is giving me only the value of that middle part, not the index. For getting the index, I have to add that initial address or the initial or the starting, right? So that's why the factor of low comes in, and actually we find it by middle element by. So if you want to find the middle value in some range, so you normally do high minus low by 2, but to find the particular place or the address of that, we have to add that initial address of that range. Okay, so many of the people use the formula low plus high by 2, right? So where does this formula comes from? This formula is derived from this formula only. So if I again do some derivations and solve this formula or boil down this formula, so what will it reduce to? It will be reduced to low plus high minus, I'll take the LCM, then it will be reduced to this. So and this will boil it down to low plus high by 2, right? So now I hope you are understanding how we are calculating this one. Cool enough? Okay. Now if now this adding low to this middle part or the middle value is fetching me the index from the left hand side, right? Now if I want to get the middle from the last, right? So what will I do? So applying the same logic, when we want to fetch the index from the left hand side, we added the low value. And now if I want to fetch the index from the last, what will I do? Think logically and feel it. We will normally subtract, right, the high value, the middle value we got, we will subtract it from the high value, right? So this will fetch me the index from the last. Okay. So this is how it is working here, right? So these are the two values. So it is fetching me the middle element from last, right? And this is fetching me the mid from start, right? So these two concepts I will be using in the ternary search also. So that's why I explained you how this formula is coming up, right? So in ternary search, I'll divide my now coming back to the ternary search, I'll be dividing my this array into three halves. So what formula I will be using for dividing, that is I will be calculating mid 1 and mid 2. So how I will be calculating mid 1? Low plus high minus low by 3, because in binary search we wanted to divide the array into two parts, so therefore we divided by 2 only there, and in this ternary search I have to divide my array into three parts, that's why I divided it by 3, right? And similarly for mid 2, right? So this my mid 1 will some, let us for assume for instance my mid 1 will be pointing here and my mid 3 will be pointing here, right? So my array will be divided into three parts, that is first part, right? And it will be my second part, and this one will be my third part. So that's how you can visualize how we are dividing the array, right? So it is logical that if we want to divide a thing into three halves, we only divide it from the initial and from the beginning. The remaining part will automatically give us the second remaining half part, right? So for example, if I say that if this is my complete a log of wood, right, and I want to divide it into three parts, so if I divide it from here only, it will give me a two part, and if I divide from the last, I'll get two part, and the third and the remaining part will contribute to the second part automatically. It will, I have just picked the first part and third part, but the remaining part contributed to the second part. So I hope this visualization is clear to you. So for finding from the last, what we did, we just used this value, but we subtracted it from last, that is high minus low by 3. So it will fetch me mid 1 and mid 2. These two formula will fetch me mid 1 and mid 2. So you can feel now or sense that if I wouldn't have explained you how this low, like how the mid came in the binary search, right, by visualizing, by making you visualize, you wouldn't be able to recognize how this formula is coming up, right? So this is how it is important to know the basic or the fundamental, in this case it was binary search, and to extend those fundamental or logics, fundamental logics to the higher one, right? So it is a perfect example, ternary search is the perfect example of how you can extend your fundamentals or basic logic into the higher one. So in this we are extending our logics of binary search into the ternary search. Okay, so now in binary search we compared the value to be found out with the mid, right, because we had only single mid. Now we have two mids, so we will be comparing these mid 1 and mid 2 with the element to be found. Now there will be arriving three cases. Uh, suppose for instance, suppose that these are my three parts. Okay, the three parts in which my initial array was divided, and if I want to, this one is my, okay, I'll draw it again for you, okay, for better understanding. Yeah, I'll draw it here. So okay, uh, mm, yeah, this was it, and okay, let it shift a bit downwards. let us keep it here only. Nice. And I'll be depicting indexes with this purple color so you can understand it perfectly. Now the numbers or the digits in the purple are my indexes and the numbers below are my values, right? So now if I if this is my mid one, we are considering, it is not the exact, but we are considering for a better understanding that now this is my mid 2. Okay, now so this one is my first part, this one is my second part, and this one is my third part, as explained in the left side. Okay, yeah, this one. So I will check, suppose if I if I have to find element number 3, right, value 3, what I'll do, I'll have two mid, that is mid 1 and mid 2. I will compare my value 3 with mid 1, whether 3 is okay. So I'll compare whether 3 is smaller than mid 1, no, right? Then I will check whether so mid 1 is crossed, right? Okay, so I'll write down the conditions also for you. In the first condition we will check if my element to be found, let us denote this by element to be found, is less than array of mid, that is right, array of mid 1, not mid 1, because mid 1 is the index, mid 1 is the index, and array of index will fetch me the complete value. So we have to compare it with the value, not the index. So just note this thing here. Okay, because these smaller mistakes can, you know, distract us from our final destination. Okay, so yeah, after this was the first comparison. So what this comparison says, if my element to be found is less than the array of mid 1, that means my element, because my array is sorted, so all the elements on the right hand side of the mid 1 will be greater than the element to be found, that is ELE. So basically logically saying that I have to shift in the left hand side, and I have to ignore both of these part, both of these mid 1 and mid 2, right? The second part and third part also. Okay, so my array will be reduced to only this part. Now in the second case, if this condition is not satisfied, right? So in the second condition, because we have two mids, so we have to check with the second mid also. So if my element is greater than array of mid 2, right? So what does that mean? That means suppose, for example, if I have to find element number 7, right? So I'll check whether my element number 7 is greater than uh, array of mid 2. Yeah, it is greater than, right? So because element is sorted, array is sorted again, so all the elements on the left hand side will not be of any of our use. So we will reject all these elements in the left hand side. So I'll be contracting my or reducing my search space in this part only, right? Only in the this part. So yeah, this is the case. Now if I take an example in which I have to find element number 3, for instance. So if I will check, I have to find this 3 element. Okay, so I'll check whether my element 3 is less than mid 1 or not. No, it is not. This condition is not satisfied for element number 3. Okay, now again I'll check if my element, that is 3, is greater than 5 or not. No, it is definitely not. It is smaller than 5. So this condition is also not satisfied. So what will we do in this condition? Because we saw the two conditions, that if this first condition is satisfied, we will be shifting on in this side only. If the second condition is satisfied, we will move to this side. Now the third condition says that if any of these conditions is not satisfied, that definitely means that it is guaranteed that our element may lie in this range. I am saying that may lie because we are not assured that the element is in this array, but we have devised or came to a conclusion that our element may lie in this, may lie. Okay, yeah, so we will be reducing our search space to this. I'll be reducing our search space to this part only. Okay, so now our search space is reduced to this, and we will be repeatedly doing these calculations and these comparisons. Okay, so if my element is found, I will be returning from that point only. So I hope you understood this complete approach, how it looks like. So now let us move down to the pseudocode kind of thing. Okay, so I'll be doing the iterative version for that, right? So in the iterative, now the pseudocode part, right? So let us first of all in the binary search, right? So you can remember the steps we perform in the let it be binary search or ternary search. There are the general steps we perform, right? In the first step, we determine the search space. So for search space, how we determine two values, that is low and high, right? The value of low and high will vary in different quotients, but in this case, if we have to find, so the low will be the index, right? So the search space will be comprising of the indexes, right? So our low will be the 0th index and high will be the n minus 1th index. Now we will do the iterations, right? We will reduce our search space by doing some comparison. So we have while condition to check or to ensure that up to how much limit are up to what extent are this like the search will go on, right? So low will be less than equal when until low is less than till low is less than equal high, we will be doing iterations. Okay, so yeah, so we define mid one, right? So we first of all found mid one by the formula, and we again find mid 2 by the formula. Okay, now as said that we will be doing checking conditions if the first condition, okay, for the mid 1 and the second condition for the mid 2, if any of this condition is satisfied, we will be normally returning 1 or minus 1, because 1 will be depicting that our element is found. So output, let me denote the output format, right? So we have to return 1 if found, and we have to return minus 1 if not found. Okay, now after clearing the output format, yeah, so these are the initial two conditions for checking. If any of these condition is satisfied, we will be returning 1, right? If any of these condition is not satisfied, so we will check whether in which side or in which half we have to move, whether in the first half, the mid half, or the last half. Okay, so okay, I'll again take this. This is my mid one. This will help us to visualize, and this is my mid 2. Okay, so now if my element to be found is less than array of mid 1, so what does that mean? Our element will be in this range only, right? So how will we reduce our search space from this to this? How will we reducing our search space from this part to only this part? That is, we all know that, right, from the binary search, because we are extending the concepts of binary search in the ternary search. So what will we do? We'll be decrementing our high to mid minus 1, mid 1 minus 1. Okay, mid 1 minus 1, because mid 1 is, because we compared it with mid 1, right? So there is no need to include that mid 1 in this next range. We can exclude that mid 1 part, because mid 1 was also less than was greater than element to be found. So this was it, and now, right, so this was my condition, and again if this condition is not met, then else, if element to be found is less than array of what, element to be found is greater than array of mid 2, right? That means this one, then we have to reduce our search space to this part. So how will we do that? We will increment, because this is my low and this is my high, right? So I'll be shifting low to this, so I'll be shifting low to this in this case, and in this case I'll be shifting my high to this part. Okay, and in this part I'll be incrementing my low to this. So I hope you can visualize it from this diagram. It helps a lot. It helped me a lot when I was in initial state of my binary search and all. I hope it will help you also. So yeah, so I'll increment my low to mid 2 plus 1. This is how we do the second comparison and shifting. Now the last case is that else, that if my element doesn't lie in any of these ranges, right, in any of these ranges, so my element may lie in this range, right? I will repeat, may lie. I'm not assured whether that element is there in this array. If it is there, then it will be definitely in this range. If it is not, then it will not be in this range, but it is confirmed that the element will not be in this part and this part. It may lie in this part, but it will definitely not be in this and in this, right? It can lie in this one if it is there in this array. So in else, let all of the second condition, all of the two condition are fulfilled. Now last condition left is, so we will only write else, and for that we will be updating my low to mid 1 plus 1 and high to mid 2 minus 1, because from this diagram above we can see that uh, to reduce our search space to this part only, I'll have to bring my low to this and high to this, right? So that will be it, right? And this will be ending of my all the iterations in the ternary search, and in the end I will return -1, because if all these iterations are completed and if it haven't returned anything till yet, that means the element is not found, because we are assured that if element is there, my this search, my all this ternary search will give me answer. It is guaranteed. But if it is not there, then yeah, when this loop is completed and it haven't returned anything, so it will return -1 automatically, because if it would have been returning something, so the control of this code would have not been coming here, right? It would have directly returned from this point only. So yeah, so that's all about this ternary search. Let us now guess the time complexity, right? So time complexity of ternary search is, we can guess now, because we are dividing every time in three part, that is log base 3n. So now there is a question now. People might think that in the first code that ternary search is better than binary search, because we are eliminating the 1/3 or the 2/3 part and we are moving in the 1/3 part. But no, if you look down carefully, if they are the recursive function complexity, then the complexity of binary search is t of, and if t n denotes that for fetching the for the binary search in n search space, right? So will be t of n by 2 plus 2, because we are doing two comparisons in the binary search. That is, what were the two comparisons? The first one was that we were finding the mid element, right? It was the first O of 1, like the plus 2 denotes the constant computations, right? So in the binary search, the constant computation is finding the mid, right? And the second computation is the second check was the checking, right? So there were two computations, so plus 2 is factor for that. Now in case of ternary search, we can guess that in case of ternary search, what we'll be doing, tn by 3 plus 4. So we are having 4 check conditions here, right? 4 because 2 for the finding mid and 2 for checking the if condition, right? The first if, second if, and the remaining 2 for that. So we can see that if we do some higher mathematics, then there comes a logarithmic, we come to a logarithmic type of relation in which when we compare, we find that there are more number of computations or checking conditions in the ternary search in comparison to the binary search, right? So almost like they are almost compute the final answer in almost equal time, but binary search is having an upper hand in case of ternary search, right? So if anyone asks you in any of the interviews that which is better, one, ternary search or binary search, so you will always say binary search, because binary search takes less number of computations and less checkings, right, in comparison to ternary search. So I can guarantee you that about 90% people don't know about this concept of ternary search and why binary search is better than ternary search. They will, if you ask them, right, why ternary search, like which is better, they will definitely say ternary search. And I guarantee that most of the people here also would have guessed that ternary search will be better, right? But no, binary search is better than ternary search, right? But if we compare the asymptotic time or the upper limit of time, so both of them will execute in almost nearly same time, right? So there is no such big difference, but yeah, binary search is having better time complexity than ternary search. Okay, so we are done with the this explanation part. Okay, I hope you understood this completely, because I have covered each and every topic, each and every basic. We started with the binary search, right? We saw how this formula of computing mid came, right? And extending that, I helped you to understand the finding mid 1 and mid 2 formula, right? And we visualize it, and with the help of visualization, uh, we computed, or we wrote down the pseudocode of this ternary search. Cool enough. Now we will jump to our coding part, right? We will implement, we will see that whether we have learned this algorithm correctly or not, and we will implement this binary search or ternary search. So let us see how it goes now in the coding part. One thing to remind you that, like, if you're not sure about your logic or not, you should, instead of searching everywhere on the internet and anything else, if you have time, then you should code, because code never lies, and if your logic is correct, then your code will be definitely be giving you correct answer, because code never lies. Okay, so that's the notion I go by. So this is our practice portal. You should have been comfortable with this, because right, we are solving a hell lot number of live streams. We are doing live streams daily on this platform only, right? So this was the question. You can read out the question that they're given a sorted array of size n and check the element k is present or not, right? So here it is given what is ternary search, right? And yeah, the question says that if element is present, then we have to return 1, else we have to return -1, right? And yeah, if this question says we have to do it in ternary search, so obviously it is asking for big of 1 search space and log base 3 and complexity. So yeah, let us now begin with the coding. So as we said that first of all we will be determining our search space, right? So let me comment it down. First of all we will be determining our search space. So how will we do that? That is, we will be taking low as 0 and high value as n-1, right? Now we'll be doing ternary search iterations. Cool. Now how will we do that? While our low is less than equal high, okay, then we computed two mid value, that is mid one will, how we can fetch mid one, that is low plus high minus low by 2, right? And mid 2 will fetch us low, okay, because we are finding mid 2 from the last, so that's why, as we discussed, we will be subtracting the middle. Okay, my bad, that is it will be by 3, because it is ternary search, we are dividing it in 3 parts, and it will be again low by 3 here also, right? So mid 1 denotes that the first 1/3 part from the starting, and 1/3, and mid 2 denotes 1/3 from the end. So that's why from the beginning, let me do from start, that's why we have added the low address, and it is from the beginning, from the end, that's why we are subtracting high minus low by 3 from the end, because as I showed you or visualized you through the pictorial diagram, right? I hope it's clear to you till now. And after that we'll be doing comparisons and checking, right? So if my k, the element to be found here is k, right? So if my k is less than array of mid 1, then right, so first of all we will check whether my k is equal to mid 1, array of mid 1 or not. So if it is equal to array of mid 1, then I will be normally returning 1, because 1 denotes that element found, right? And if my k in the second comparison, if it is not equal to mid 1, then I'll check for mid 2, right? So if my k is equal to array of mid 2, then again we will be returning what? Return 1, denoting that element is found. So again I'll comment it down, that is element found, right? Now after checking all these, right, now we will check that if both of these condition is not satisfied, as we discussed in the pseudocode part and the discussion of that ternary search algorithm, we will now check if my k is less than array of mid 1 or not. If it is, then I will be searching in the leftmost 1/3 part, right? So for that, what I'll do, I will do mid 1 minus 1, right? And else, if my k is greater than array of mid 2, that means the mid 2, that is the last 1/3 part, then I have to shift my search space in the last 1/3 part, right? So for that I'll be doing mid2 plus 1. I hope it's clear to you till now. And then if both of these conditions are not satisfied at any iteration or at any point of that complete ternary search, then the last step we are left with is finding in the middle part, right? The middle part. So the middle part says that for reducing our search speed to the middle part, we will be doing low is equal to mid 1 plus 1, right? And our high will boil down to mid 2 minus 1. So after that, all these searching or all these comparisons are done, and if it hasn't returned in this part, then it will definitely return. That means that our element is not found, or element is not in that array, and we have to return -1 for that, right? So -1 will denote element not found, right? So one more thing I will comment it down for you so that you can understand later on if you revise this code, that reducing to leftmost 1/3, right? 1/3 part, and in this we are reducing to the what, rightmost 1/3 part, right? And in the last option left, if any of this condition is not met, so in this we are reducing to the middle half, right? So yeah, let us now recheck our code, because one thing you should take everything into your practice, and you should be habitual with that before submitting your code you should recheck your code again, right? And try to practice that you should make your code submit in one go, right? So don't always try to press the submit button, and before submitting the submit button you should check your code again after writing down. So I'm telling you this because many of the fan companies like Amazon and other companies, now it is a practice that they let you write down the code in the Google Docs and something kind that, and they want you to write down the code in one go only, right? So that's why I'm telling you that. So it will surely help you in your future endeavors, right? So what we do now, we define int low equal to 0 and high equal to 0. We determine the search space here. Now after new search iterations, low less than equal to high correct. We have found mid 1, the formula used is correct. Mid 2, the formula used is correct also here now. Okay, so we checked whether our k is equal to mid 1. If yes, return 1. If k is equal to array of mid 2, return 1. If any of these condition is not met, then we will check whether in which half do we move, right? So we are reducing to leftmost 1/3 part if this condition is met. That means if array element to be found is less than array of mid 1, that is correct. If array element to be found is greater than 1/3 last part, so yeah, it is correct also. Now this one is also correct. So we will submit it, and I hope it will get submitted in the one go. Boom, it works, right? So yeah, this was all about this ternary search, right? I hope you have enjoyed this video and understood it completely, right? If you have any doubt, you can write down, comment it down. We will surely get back to you as soon as possible, right? So guys, stay tuned for practice channel of GFG, right? And subscribe and like and hit the bell icon for more notifications, and so that you can be notified every time when we go the live stream. You get notification for that, and you enjoy and gain knowledge from these live streams and the problem of the day, right? So yeah guys, happy coding. Bye bye, take care.